Welcome, guys and girls. The good, the bad, and the ugly of event sourcing. Well, just the first check. Who actually is using event sourcing? Oh, a couple of people already. I'm surprised. So you already know the good, the bad, and the ugly. Or not? Okay. So my name is Dennis Doomen. I'm from Holland. I work for a small consultancy firm. Yes, I'm a consultant. Sorry. Although I'm usually a consultant that sticks around. Am I too loud? Because it sounds really loud. Okay. I call myself the continuous improver because I'm continuously improving myself. At least I try to do it. As a speaker, as a consultant, I look at architecture styles, I look at coaching and agile aspects and culture of teams and how to get people work together. So it's pretty broad. That's what I blog about. So, yes. Yep. 19 years, actually it's 20 by now. I do something in the .NET space called fluent assertions. You may know that if you're a programmer. Any programmers here? People actually code for that data? That's good. At least I know my audience. Event sourcing. So since there were only 3 or 4 people that raised their hands, let's do a little bit of a summary of what event sourcing means. It can be pretty technical. So I have a web application. A web application sends a command. It's not called change, well in this case it's called change user email command, but it's supposed to be something from the ubiquitous language that we've heard so often today. So kind of change is a bad name, it doesn't say anything, but just for the sake of the discussion, we'll just call it change user email command. That goes into a command service, which is kind of a broker. It will then find a command handler for that, something that knows how to handle this particular business request, which will go through some unit of work and go into an event store and say, give me the user with that identity, because I'm changing the user, I'm changing the email of a user. So I need to know the identity of that person. It's probably part of the command, which I'll then send into the event store. Then the event store will load the entire history of that user from the database. So there's no record or something like that in a relational database. You have a record called users, you can select one and then you have all the characteristics. No. You're actually loading the history of the object. So the fact that it was created at a certain point of time, that it got roles assigned, then this person moved to a different location, maybe because its address was wrong, or he actually relocated as a person, the entire history. And at that point, we have like runtime a user object, which is then initialized with its own history. Before that, there's nothing. Then the email handler will actually say, I'm going to invoke a method on the user. I'm going to actually change the email address, at which point an event is applied to itself, which changes the actual email address. Like, okay, wait, what, really? All right. So we can go further. Then at the end, we tell the unit of work, like, now it's time to save those changes back into the event store. So what does the event store do? It asks the user, what is the change that was applied to you at runtime? And that is stored into the event store database, which is a write database. Coincidentally, this is also CQRS, Command Query Responsibility Segregation. We have a write side, which happens to be on the right of the picture, and we have a read side, which is not here, because the problem is with event stores, you can't read from it. Yeah, you can read from it, but you can't query for it. You cannot say, give me all the users which are from Berlin, as an example. You can't do that. Because it's just, if you would literally look in the database, it's a flat structure. And it can be like a relational database, like SQL Server, but it can also be a NoSQL solution. That's all fine. So we need something on the other side. We need something called a dispatcher. This dispatcher will find something that we call a projector that takes that event, the fact that the user email address was changed, and projects it in a structure that is useful for reading through some data access layer. Can be anything. Can even be an ORM if you want to, object relational mapper. Then the web application can say, I now want to know, I want to find all the people from Berlin. So it executes a query and not necessarily a SQL statement, but it's more like an object-oriented, high-level representation of a question. People from a certain country, a certain city, which goes into a handler and that loads it from the data access layer. That's it. That's event sourcing. That's all about it. Nothing special about it. So why is it so cool? Anybody old enough to recognize who that is? He's still alive, actually. I'm surprised. I'm awaiting it. It will soon happen, but so you can do some cool stuff with it. For instance, this is a simple representation of a domain. Again, a domain event store. So you can project it in multiple ways. The point is, these projectors are optimized for their purpose. So it's actually possible that the same data is projected multiple times for redundancy purposes. It is like if you want to have a count per city, like the number of people, the number of users in your system per city. You can, of course, do like a count with a grouping and everything in SQL Server. But since the information only changes when the event changes, you can actually build a projection that is specifically targeted for that purpose. It already contains a simple table with the city and the count. And every time somebody moves into that city or a user is created, we update that particular projection. That's really efficient. You can use raw SQL, but you can also use something in the .NET space like Dapper or something like an Hibernate or Entity Framework, if you really want to. You could even say that, that the database that it stores in can be a separate database. Every projection is autonomous, which means you can store it in separate tables or even a separate database. Maybe one database is local, which is great for sharding, obviously. You can also have something that maybe runs more asynchronously. Like some things, especially if you have a user interface that resembles a bit of a CRUD solution, yeah, you click on a button on the page and you execute the command that issues changes on the domain. You would expect that after the command is executed, that your projection is updated, that the data is already there. But it's far more efficient to do this in the background. Have a projector that builds up a completely different representation of that. It can run asynchronously, that's why I have this dotted line here. You get more of them. You can even say, like, you know what? I have this projector, and the only thing I really need is an HTML page that provides some small statistics, like a KPI dashboard. Why would you render that when people ask for it if the actual data underneath it doesn't change? You can even generate an HTML as part of the projection work. So it's already on disk. So if somebody does a web request, it just needs to serve like almost like static content. You don't have to, but you can. These are options. The thing is, an event store is something that represents the history of everything. So you can even use the event store as something like immutable. It is immutable. Events don't change. They have happened. You can never change that, which is great for SOX compliance or something like that. It's also a restriction, of course. But we use them quite often as a kind of audit representation. Even in the user interface, we display a list of what happened to this user in time, what roles were assigned, what roles were revoked at what point in time. But maybe you want to have like a temporal representation. You want to have a page in the application that shows the state of, for instance, a legal document at a certain point in time. So you can create a projector that builds up this history based on a certain point of time. It doesn't actually, and go all the way to the end, but it stops at transaction 3, which maybe happens last year. So you can create a representation that shows you what was the state of this legal document on the 1st of January 2017. You can basically play back and forth. Because, yeah, you have the entire history. You know exactly what happened there. Reporting is a different thing, yeah. A lot of people ask me, like, okay, so these projectors and projections are really optimized for a particular UI concern, or maybe an HTTP API endpoint that you want to expose. But what if you want to have these old, reporting solutions? You want to be able to do the data mining, or you want to connect your system to a Cognos or whatever a BI solution. You're not supposed to use these optimized projections. But what you can obviously do is just build another reporting model based on the same data. So you take the same events and project them in a structure that looks like a traditional relational database, which all these BI tools people love. Make sense? Huh? I know it was heavy. And obviously, since this reporting projection doesn't have to be in sync what the end user is doing, it's just a reporting database, it may even live on a separate machine. Like you don't want to affect the production environment with some reporting solution because you don't have a clue what kind of queries people execute when they do data mining. So just put it in a separate machine and create a cube from that. You can. You could put a bus in between. Another cool thing is you can do like functional conflict handling. You can actually make decisions how changes to the same document, object, or whatever, on different times, different places should be merged and should be handled. You can involve the business with that. As an example, I have here a user which was created, then a role was granted, and then his phone number was added in this weird cutoff way. That's the history. Then the red line represents the current time. So after that, on a different environment, different machine, or just a different session, it's all possible, a role is granted. Then at the same time, the password is changed. Maybe there's some background process that changes the password of that user. Then you have another password changed, which is perfectly fine. It can happen. Maybe there the end user was directly changing his password. We're talking about the same object in the system. The role was revoked again for some reason. Now the question is this a conflict functionally? Because that's the essence here. Is that a functional conflict? Probably not, eh? Why would it? No, it's not. Is this a functional conflict? No. Depends actually. Because if one was actually granting a role, the other one's revoking, it is possible, although it's a bit weird because they're on different machines. But again, it's a functional discussion, usually with your business owner, product owner, how you deal with that. Is this a conflict? Oh, actually, that's wrong. So the point is that after we discover or we identify that this is not a conflict, what happens is that event is basically put on top of it. So we kind of merge the history. But that password change that also happened, is that a conflict? Could be, probably. Which one wins? Again, that's a functional discussion. Maybe we say, you know, the last password in time, and of course, if there's only 5-minute differences, then that's difficult because servers usually have a 5-minute differences. But in this case, we decided it's not a problem. We just take the last one. Is it a conflict? No, it's not. That one, probably not. So we just end up at the end. And then the same thing happens, go from left to right. It's also possible. This is even cooler. Let's say you have this event store. You see these changes on the right side with the projections, the query data on the left side. And you want to be able to support like a kind of replication scenario. You can obviously do that on database level. But you can also do it on the application level because you have a nice history here. You have like a numbering range that goes up from 1, 2, 3 until a certain point. And the last number, you can't really see it if you're in the back, is 6,289. This one is even further, it's 6,301. So you can already see like how far did they get. You have a really natural unit for replicating data here. Because what we call these numbers are usually a couple of events, things that have changed that happened at the same time. They're small, just a little bit of data. So it's an ideal unit to replicate. But you could go further. You could even say, because you're replicating the event stores, and the event stores, I already mentioned that before, are immutable. The data is immutable. So, and usually these technical structures that are underneath here, they don't change that often. So you can even say, you know, this is version 1, this is version 3. And version 3 will probably have different projection data because the product requires maybe different data. They may have extra projections. So the idea is that you just copy over the data to the new environment. The new environment sees, hey, I have an event. You know what? I'll project it to 4 different projectors or 4 different tables or whatever you want to call it instead of 3. Options. Another one, it's another cool thing, which happens a lot. Your domain, does your domain change? Probably usually does or not. Your domain changes, not something the business changes, the requirements change, so your domain changes. So let's say I have an aggregate root, which is a DDD term for those who haven't. You have a couple of entities and a value objects. As I said, everything that happens in your domain is persisted as a stream of events, things that happened in time. So what you could do, store it in the event store, and then say, later on the new version, I'm going to redesign my domain in code. I mean, in code it looks differently. And I use the same events to project them or to rebuild my aggregates in a different way. So this is not about projection, it's about dehydrating, like I just mentioned, that the user is created and then the history is loaded from the event store, and that is used to initialize it. Now I'm saying I'm going to redesign the actual domain, but I use the old events to represent that, to parse the data. It's not parsing, it's basically things that have happened. Because, and that's cool about event storming as well, events don't say anything about the structure of your aggregates. They just tell you what happened functionally. So if your business rules change, and DDD is all about invariants and protecting them and transactional boundaries, you can actually redesign your domain, use the old events because you knew what happened, you just interpret the data in a different way. You can do that. However, with all these goodness stuff, and it's really cool stuff you do, I've been using this for 7 years, there's also a flip side. There's a lot of stuff that's not that great. I call it bad, but it's not. Wrongly designed aggregates. So who's really experienced in DDD, or I shouldn't say experienced enough, aggregates? Yes, obviously, yes, aggregates and stuff. You can do a lot of things wrong. You can, for instance, define your domain based on ownership. That's like I made that mistake. It's a rookie mistake. I have a product, I have an owner, or I have a catalog, and no, I have an order with products. And I thought, okay, so I need an owner. Sorry, I need an order, I need a product, and I need to connect them together. Like we used to do before DDD, we actually modeled everything based on structure instead of whatever you need to do, which I just explained. But we do it in a simple way. That's a really rookie mistake. Relying on eventual consistent projectors. So as I said, an aggregate or a domain, you can't query it. Sometimes your business rules may be so complex that you cannot design your aggregates to protect those invariants in a good way, and you may need to query somehow. But the problem is in event sourcing, your projections are always stale. They're just a representation of time, of the things that happened. But it's not transactionally in any way. Lots of people, especially on high load, all these events come in, or commands come into the aggregates. They end up a lot of events that happen. So your projections are never completely in sync. You need to think about that. We made the mistake a couple of times of trying to assume, yeah, you know what, these projections are probably fine. And then suddenly blows up in production because you made a mistake there as a race condition. Something to think about. Or a functional key. Aggregates are identified by something. So you choose a user, like we talked about, the user has a username. That sounds like a decent functional key. Until you start to integrate with something like Active Directory, and it's possible that the two different persons have the same username. It is possible. And then your system blows up. We had that, and then we changed the username into a GUID, which is not a problem in itself. But all your aggregates, the entire event store is filled with events which are identified by their username. How are you going to correlate that somehow? That is a painful mistake. There's some tricks you can do with these deterministic GUIDs, which is a bit of a paradox because GUIDs were supposed to be unique, but you can actually generate GUIDs from strings in a deterministic way. If you want to know that, ping me on Twitter. But you have to think about it. These are things, I mean, they always say that architecture is about making trade-offs, but also you have to really think about the point in time where you make the decision. Decisions that are hard to change, you have to make them now. Decisions that you can easily revert later on, you can postpone that. That one is difficult to undo. Everything is possible, but it will create technical debt. I have technical debt. I have lots of technical debt. Do you guys have technical debt? No? Yes? A couple of people have tech. The rest doesn't code. I heard somebody say, like, if you haven't built a monolith, you've over-engineered your system. No monolith here? No? I can see that. Yeah, I can see the eyes. I see everybody like, oh, my food is so heavy on my stomach. Running a business logic after, like, your aggregate has a business rule, you've made your change. It's really convenient to take those domain events as things that are raised in your code base, and you can react to that. The mistake we made is, although these events indeed have happened, the domain has accepted the change and issued an event, we then use that event to kick off other command lines or other commands. And these could fail. So we started to create like a chain of aggregates that raise events, but some of them could actually raise rule violations, or basically violations that cause exceptions to occur. We kind of relied on that. Well, it was a mistake. People wonder, like, why would you do that? Well, there's an old domain event pattern before event sourcing existed. Anybody know Udi de Haan? Udi de Haan? He's been publishing a lot about domain events, and they actually bring you in the wrong space here. That's another mistake we made. We thought actually like it's really good idea to encapsulate all our primitive types into real domain-specific value types, like an ISBN number, or something that represents an email address, which is then called email or email address or ISBN, which just wraps the string with as business rules. We thought it was a good idea because at some point, you know, remember that username thing? So we had strings to identify users all over the system. Then we switched to GUID. I thought, oh crap, now we have to update the entire system. Everywhere where we use a string to identify a user, and the user is a pretty common term, we had to change it into GUID. And then we thought, you know, dry, don't repeat yourself. Let's wrap that GUID became into a value type, which we call user identity. And use it everywhere. Because, yeah, with every principle, you have to apply it really dogmatically. That's how it works, until you realize that's a bad idea. So we even put it in events. And that's painful, because these events are written into an event store and in some kind of serialized format. And then the value types change. The rules for an ISBN number or email address change. So you dehydrate an event from the event store, and then the code says, hey, but that's not a valid format. Yes, it was. It used to be. Don't do that. And that's another one. I learned that yesterday from my French colleague over there. Aggregates that grow too fast. Maybe your aggregate generates lots and lots and lots of events. I mean, at some point, the system will collapse. You can use snapshots and stuff. Most event store implementations support that, which means you don't have to load the entire history. But if you have like millions of records, yeah, then maybe you have to think about ways of saying, you know, I don't need to keep the entire history. So after a month, I kind of collapse the entire history in a new event and create a new aggregate from that and delete the rest, like archive it or something like that. That's a cool thing. I didn't even run it myself, but I heard it from a guy over there that can tell you a lot about that. So finding the right aggregate boundaries. Has anybody read the article? There's a 3 PDF part written by Von Vernon about effective aggregate design. No? If you haven't, it changed the way I look at this stuff. After reading those, I was like, okay, I've been doing it wrong. I have that. Every couple of years I discover I was actually doing it wrong and I should do it differently. Sometimes even during a conference, I'm doing a talk and people say, yeah, you're doing it wrong. Like, why? Okay. Oh yeah, I did do it wrong. And then I changed my mind. Nothing is set in stone. That's the profession of an architect. Things change over time. You change opinions. So he actually says, like, okay, you do a couple of things. You first talk to people. You ask the difficult questions. You try to identify, like, what are the invariants in this domain within the context of a particular region? We have bounded context. A lot of people have talked about that. Understand, like, if this happens, then this should happen. But does it actually have to happen at the same time? Does the system, for instance, have to guarantee that certain invariants are never violated? That also defines how you're going to model your aggregates. If something can be compensated afterwards, you can use like compensating actions that happened out of process or not in the same transaction. It defines basically the transaction boundary. Von Vernon is much better at explaining that. Understand the real world. Even Eve talked extensively about that. Understanding the real world is important. Developers have the tendency of interpreting that real world and creating their own world and then building it like that, and they end up with the wrong thing. I did it. I'm guilty of that. But use a couple of guidelines, like driven by invariance, not composition. As I said, don't define your aggregates based on who owns what. An order owns a product, or an order has a reference to a product. Don't do that. Think about what business rules it needs to protect. Accept the fact that you can only be consistent within the aggregate, so within the aggregate root and its entities. Again, these are guidelines. They're not set in stone. It's possible to do differently. In my system, it's even possible to touch multiple aggregates in the same command, which is a violation by all the purists, but I don't care because I'm a pragmatist. I need to actually deliver systems. So I sometimes have to violate the rules. That's the job of an architect, to make the trade-offs. Define small aggregates. That goes without saying, but still lots of people create huge aggregates with like lots of data in there. And reference by identity, especially if you come from the relational model, and even more so if you use ORM. So you have these properties that reference other properties, and if you navigate through that property, your ORM will dynamically load the other entity. That has to be changed. That doesn't work anymore with event sourcing. Again, this is all common knowledge for the DDD enthusiasts, but these are some good references. I added that to the end. Some practical challenges. How do you code it? This is C# for those people. What are .NET people? Okay, Java also. JavaScript? That's not a real language, is it? Is it? Haskell, Elm, F#. Not a surprise here. Anyway, but one of the things is like, how do you do that? Because you have this code, you can see it here, the cancel method. It basically verifies the constraint. You can only cancel if the actual thing is in process. In this case, it's an order in progress. Then it applies an event to itself, order canceled event. That is this little thing that I was just describing. It applies an event on itself, and then there's another method that knows, like, okay, if this event is applied on me, either because this business rule, this method was called, or when the aggregate is loaded from the event store, the order cancelled event is applied, and that actually changes the runtime state of the object. Well, you can do that in one class, but then it becomes a mess. You can also do it like this. So you have one partial class, and that's what you can do in C#. I don't know if you can do that in JavaScript. One class that actually contains all the business methods and what they do, and then you have a separate class, in this case a partial one, that updates the state, so you separate them a bit, because the right part of this picture is not something you care about too much. It just happens. It's just more plumbing, actually. Or you use something like a state class. That's what we do right now. Neither solution is nice. You can also use frameworks that do all kinds of magic. Well, I don't like framework, especially if they apply magic. I like to understand what happens, but that's why. That's a way. You also have a talk about event granularity. Like, do we have something like a risk assessment level changed? And because of that, the risk assessment team needs to be removed. So you have this system that talks about permit to work kind of environments. And they say if it's a level 1, it's all fine. But if it's a level 2, you need to set up a team with people that do the assessment of the risks. And we're talking about doing maintenance on an oil platform or something. But if the level demotes, if the level actually changed back to 1, you don't need a team anymore. So do you represent that as an event that represents the risk assessment level change, then the team that was moved and another one? Or do you just say you try to think about event storming? You would probably come up like the risk assessment level is demoted. Neither solution is optimal. And there's no ultimate answer to this. It also depends on the system. Because the left one is great if the business rules change. If the business rules change over time, you still want to have this history that if the level 2 was changed back to 1 and the users were removed, you want to keep that. But if you represent it on the right side, like a coarse-grained event, then it's up to the code implementation how that's handled. And if that changes over time, you get like a discrepancy. All data is suddenly showing a different behavior than we used to, than what we expect to. This is the most difficult part, I think, in event storming, trying to figure that out. Versioning. So I have this big event, and it's called risk assessment level change, and it lives in a namespace, and it's in a certain DLL, which contains the actual code. What if somebody says, and especially in the .NET space, use all these refactoring tools, renames that to something like, instead of domain.riskassessment, they've called it threat-assessments.risks.domain. And maybe they even extracted it because there was one big DLL called domain, but we love refactoring, so we ended up with something called threat assessment DLL. We even changed the name from level change to downgraded. You have the existing data in the event store, and how do you handle that? Well, you basically have to create a conversion code for that, and that's painful. So we have events that are called V1, V2, V3, V4. We keep everything in the code base. We just put it in a separate folder. Because, yeah, that's the history. It's in the database. It's in the event store. You cannot undo that. You can reconcile that. There's a nice article that I referred to at the end of the presentation that talks about different ways of reconciling and aggregating data, especially if the database grows really fast. There's different ways of doing that. You could, for instance, say, I'm going to read the old event store and apply all the conversions as part of that and write that to the new event store. You're violating this immutability thing, but what you essentially are doing is just aggregating the old data so that the new database only understands the new event types and then throw the old stuff away. You can't do that. You don't have to. But there's something you need to be aware of. And it happens a lot, especially in domains that change. Yeah, rules change, and especially if the ubiquitous language changes. I mean, DDD is all about breakthroughs. So if you discover that the terminology that you've been using is not the correct one, you change it. And if you change it everywhere. In code, your documentation, UI, everywhere. That's important. There's only one language within a bounded context. Now the ugly parts. Testing scope. So I have this little picture here again. There's again a domain, again an event store. Now I have this stuff here, and I'm walking to the left. I should actually also walk to the right. Projectors. The projectors are responsible for doing the work, which are then, they create projections, as I said, a representation of those events, which are stored in the database. So what is the testing scope here? What would be if you create unit test, what would you actually test? What would be the scope of this? Just like get some feedback.
Unit test in the domain.
Unit test in the domain. Yeah, that's one way. Yeah, that will work. But if I want to test the fact whether my projector is doing the job it's supposed to do, what would be the testing scope? A class, a unit test per class? Anybody that usually does it? Yeah? So you could say maybe I need to create a test on this API controller. So I create a test that if I call this HTTP request, that it actually calls my projector or my projection or my API or my DAL, my data access layer in a way by using fakes and stuff. You can do that. You can also say I'm going to test the projectors and the projections. So I create a projector, I write an event in there, and then I verify that this projection has been updated in memory. You can do that by faking the event store. Does it sound like a good idea? Yeah? There's no stupid answers. What about this? This is what I do. Is this a unit test? It depends on your definition, actually. What is a unit test? It's something that runs fast, independent, has no side effects, doesn't depend on any I/O boundaries, no physical disks or databases. Can be run in parallel. That's kind of my definition. While these days, your query store can even be an in-memory, I don't know, NoSQL database or SQLite. That's a nice alternative. Runs in memory, doesn't touch the I/O, the disk at all. And your event store can be an in-memory, I don't know, store. So you test the whole thing. You actually have a unit test that shows you all the events that you apply and which order. And that verifies that your API in this case, because we don't care about this is just an implementation detail, that my API returns the right data. Even APIs can be tested, especially in the .NET space. I don't know about the rest. We can create HTTP endpoints and host them completely in process without even touching the network stack. That is something we can do these days. So with that in mind, and again, I've talked to a couple of people today, architecture is not just about architecture. Architecture is also about tools. Again, tools are not a driving force. Technology should not be a driving force for architecture, but they can enable things that wasn't possible before. In the .NET space, this was impossible, create an HTTP endpoint and not touch the network stack. But these days with Owen, which is the open web interface, you can do stuff. So this is the way I test that right now. Because events are my contract between the right side, the event store side, the domain side, and the left side. So I really would like to test the fact that this is the contract, this is the boundary, like what happens if the events end up here. All the other stuff, for me, is just implementation details. Make sense? So people that won't perform, that will be extremely slow. No, it will not. It's really fast. And the fact is, even if you completely re-implement the projection that's underneath being used because it wasn't fast enough, you can't do that without the test failing. Because the test only shows you some events that end up there and the HTTP request that's being done and whether the result is correct. How that's stored, we don't care. All right. Rebuilding things. So you have this huge event store, it accumulated data from, I don't know how many years. It's a lot of data. So then your projection scheme changes. Then what? You need to somehow rebuild that. Well, that's painful, especially with large databases. So what you can do is like side-by-side rebuilding. So you can potentially say, I have this old set of projections, maybe even a SQL Server or Oracle or Postgres, and now I'm going to a new version, going to build a completely new set of projections. Perfectly fine. You can even automate that, like that's why we call the blue-green thing. So the system actually knows I'm building a new set of projections. The old environment still uses the old data, and you use a mechanism that the data is, like, as we said, this replication process can even happen in process. Build a new one next to it, and as soon as the new data has been projected, we switch over, I don't know, HTTP endpoint using a load balancer. You can completely automate that. It still needs to do all the work, so it will take some time, but you can automate it. You can think about archivability of data. So we have something like a permit is associated with a risk assessment, and usually there's some kind of isolation document explains what people actually physically have to decouple the equipment on the oil platform. If all of them are closed, because they're generally short-lived documents, they're separate aggregates, we mark that separately somewhere, and we say, okay, now the whole graph of objects is closed, which means we probably don't care about it. So after 30 days, we kind of marked the event store. We extended the event store with a separate column, saying this graph of objects, these event streams, they're associated with that, are marked as archivable. They're not deleted yet, they're just marked as such. They might be deleted in 90 days because we moved the data into some kind of archiving solution, but that means that the next time you need to rebuild all this data, you need to build your projections, you could actually make some educated guesses like, you know what, all the data that is now marked as archivable, that's all data. We probably don't need to rebuild that right away. We only need to rebuild the rest of the data. That's pretty recent, the recent data, so that the system can become available again. And the rest we just project in the background, because it's just all data. People generally don't need that every day. They just look for it regularly. So you can make a distinction between that. It does mean you need to something like a projection tracking, because you need to be able to tell the end user how long is it going to take before this data is actually available. You know, they start to search for closed permits because they want to make a copy of it, and they can't find anything. That's weird. They just got a new version, and it became available really fast, but they start to search for closed permits and it's not there. You need to have some visual indication that this data is still being processed. So you need something to track how fast it's going. Maybe you can calculate on average, like based on the current situation, that it will take 2 hours to complete that work. You want to display that. Or maybe it's just enough to display, like, you know, you're looking at data from a couple of months ago and it's, you know, being updated all the time. It's just like a functional discussion you need to have with your product owner. You can even may say, like, some data is more important than others. So after the upgrade, we focus on the data that's really important. Like maybe they have a KPI dashboard that when they go into the application, into the system, the first thing they want to see is that KPI dashboard. So you want to make sure that after the upgrade, you make sure that those projections that are needed for the dashboard are updated first, rebuilt first, before you do any other work. That's all possible, and that's probably the way to go. Or partitioning. Especially if there's a lot of event store data, most functional objects have some kind of natural partition key. Like what I just talked about, the permits. Permits actually live on platforms, and they are associated, the concept for that is a site. So each platform is a site. So maybe you can already start separating the data based on the site. Every aggregate is always living within that functional site. You can use that to separate the data, create multiple partitions in your database that can be upgraded independently, like I just made, like a staggered rollout. Only the important sites first, and then the rest. Dynamic rebuilding, yeah, that's also something that you need to think about. There's a bug in production, and then somebody applies, like your support team applies a hotfix, which means like update SQL or delete SQL from, yeah. Then you sometimes want to rebuild that projection because there was a bug in there. The rest of the system is just working fine. Nobody's bothering with that. But that one needs to be rebuilt, so you want to have some mechanism to support that. Idempotency of projections, especially if they're partially rebuilt, you want to be able to have the projector code understand what it means to have a partial rebuild. There's a couple of events that are just projected again. Will it completely fall apart? Well, you need to take care of it. That is painful and difficult to do. And as I said, like all these projections, they are all optimized for a particular request. So all this data is stored in a redundant way. And not in a redundant way as if one dies, the other one can take it over. Everything gets duplicated. Maybe the same data is 4 times, 5 times. So when we moved from a traditional relational model to event sourcing, our database exploded in size. And our client's like, what the hell happened? I just got a new version from you, because this whole migration was completely transparent. We did it by entity, but the database was like 3 times as big. And every release, the database gets bigger because we store more data, we aggregate more data. You need to be prepared for that. But these projections can also crash. Preferably they crash during the upgrade, because then you can still switch back to the old system. Unfortunately, more often than not, they crash while you're sleeping in the weekend and you're being called because something happens. And if you're lucky, it crashes with a clear exception. If you're unlucky, your projection gets somehow corrupt. It doesn't crash, but the data is not correctly projected in some way. And that doesn't really surface until people start to see weird stuff. They look at the data, the KPI dashboard shows stuff that, like, everything is fine, and they go to another page and, you know, find all the permits, all the documents for that state, and it doesn't make sense. It's not correct anymore. For instance, column constraints. Like, initially, the ISBN number was supposed to be 16 or 20 characters. But then somebody decided that, okay, that's wrong, actually, because the developer was looking at, like, an ISBN number has to be 14 characters and nothing more. So they changed the structure. Or the other way around. Yeah, the description of this document was supposed to be 1,000 characters max. And then somebody thought, like, oh, you know what, it's .NET or something, I can just change the max length in code, set it to 2,000. And guess what happens? During projection, it tries to write that record into the database, and you get like a truncate exception or something like that. Again, you have to make sure that you handle that. Of course, you can set the database column width to far max or max far or something like that, but it has performance implications. And, you know, projections are supposed to be really fast. So you actually need to make sure the data is always truncated, just to be sure. And that usually that's fine, because the projection is not used by everything, it's used by a particular part of the system. Or a data invariant, we have that as well. Like, in the past, a particular property of an event was nullable. Nobody knew that, because, yeah, that was like 3 years ago. In the meantime, the business rules have changed, and now it's required. So somebody creates a new projection that kind of assumes that, I don't know, the site code or the location of a user or his education level is always there. And if you look at the code, it looks like it's always there. But in history, if you take a really old production database and try to rebuild it, it will just blow up in your face. Because that code wasn't prepared. It wasn't always required. You can't easily see that from the code base. This is something that happened to us. Or projection dependencies. Some junior developer thought, like, hey, you know what? I have this projection, and I need a list of time zones for each site. Oh, we have a separate table for that. So just use it. Until these things start to run in different speeds, then suddenly the projection is relying on some data that's actually not completely up to date. Not represents the state of the projection when the event was processed. You get the wrong time zone, which might not be a big problem. You don't even notice that until some people start to complain in production about time zones not correct, or, you know, date-time related calculations are off. Partial replays also have that, like a projection that creates an object, a record, then updates the record a couple of times, and then deletes it, because the data is no longer relevant, doesn't really matter what it is. Then, because of transaction boundaries or bugs, it gets replayed a little bit, so the projection is supposed to restart again. What might happen is that it actually restarts just before it deletes. So the actual data is gone, then there's an event that was supposed to update that projection, and depending on how you deal with that, most people just create a new empty projection, which is fine, is being created, then written into the database, and then all these non-null constraints are starting to complain, because you haven't replayed from the start, you only replayed partially. It happens with us, because we're doing things in batches. Like 1,000 events were handled, then written back to the database, then another 1,000. But if you replay halfway, you get like really weird scenarios. And you don't think about it until it happens. Like, oh, really? Is that possible? More? Yeah. We changed some of our projections from synchronous to asynchronous. Because, yeah, we started, as I said, we started with a CRUD-style application. So all our projections were basically running in the same thread or like thread of control as the commands. And as a result of that, everything completed. So when you press save or you click something in the UI, after that, the projection was updated. Then we changed it into asynchronous. And then it appeared that some projects actually had bugs in there. Again, something you will not find during testing. They probably pop up during production time, when people start to complain. Or worse, assuming an order of events. People have been working in the domain, in the aggregates, really well. They know exactly how things will play off in time. And what they then do is sometimes in the projection code, make assumptions. They know that this thing, you know, we first change the risk assessment level, then we remove the team, and they know that. So they actually build code that relies on that. It's not like they're stupid developers. It's just really, you know how things work. And you make assumptions about that. It's really difficult to spot. And everything is fine until somebody decides to change the rules a little bit. And then suddenly the events get reversed, like a different event gets first or something like that. And it can be really complicated domains where you don't even see that thing happening. There's a pull request merged, and then in production you start, or maybe during rebuilds, it blows up in your face because there was some implicit dependencies. Again, not something you can easily prevent. Bugs, duplicate child records, like an order table which has all the product IDs associated with an order. And there were bugs in code, like especially if you use ORMs. It's possible that we've seen that actually under high load that suddenly 2 of the same IDs were added to the same table as a child record. It's something you may not actually expect, but it can happen because of bugs. And if it happens, suddenly projections fail because there's some unique constraint that's violating. And then you look in the system, you get the production database for a client and trying to figure out what happened in time. Yeah, you can look at the event store and you see everything is fine. The entire event store looks perfectly okay. There's nothing wrong. This event happened after that, so that should be fine. But still, and it takes a lot of time diagnosing that. Or we had a bug that somebody forgot to say if the username has changed or not, has actually changed, then we apply a username changed event. But they forgot that. And there was some Active Directory import job running in that system, which was running for a couple of months, importing the same user and actually injecting new username changed events on the existing event store. So we had a simple user object, which is supposed to live long, but have only a couple of events with 1 million events in there. And of course, you don't see that until you start rebuilding the projections, and the client is saying like, yeah, you know what, it's running in the background, and yeah, it's actually saying it's 3 months behind. Why is it not going faster? I don't know. So you really have to go into the event store and get the production database again to figure out what happens. It's not something you can see from the outside. These are painful things. Or you have a lookup. You have a projection that wants the time zone of a particular site. And it creates a local lookup for that, and that lookup is privately owned by the projection. But they think, like, you know what? Time zones don't change that often. I'll just use like an in-process cache for that. But then there's a caching error somewhere, and the data is built using the wrong lookup data, just like I mentioned before. Yeah, these things don't pop up easily. They only pop up when people start to see weird stuff, weird calculations. That's even worse, identity case sensitivity. So we use the natural key of an aggregate to store it as an identity in event store. So what if this natural key is a string, text-based? How should it deal with the fact that sometimes people use uppercase or Pascal case? I actually see people log in with their names with nice first name instead of just a username. What is the difference between Dennis with a capital D at the beginning or Dennis without any? We didn't think about that. We just used the string literally as a value in event store. And that worked perfectly fine for months until somebody decided to create another user with a different name, just one capital letter. Yeah, from string perspective, these are different things. So suddenly the event store was perfectly fine with it because, yeah, these were different values and you can uniquely identify the 2 different aggregates. But the projection was trying to insert a record with the name username in SQL Server. If you're using that, you know it's case insensitive by default. So suddenly things have to fall apart, just like unique constraint violation. Like unique constraint violation, why? And if that happens, how do you fix that? I haven't figured it out yet. We actually have a problem like that as we speak. And we're still trying to see. Probably it's good to always use lowercase or something, just do 2 lower. Haven't made up my mind yet, actually, how to solve that. And this is a nice one. Do you actually know if you're in a high load and you use something like SQL Server, that if the commits get inserted really fast, the events are inserted at a really high speed, it's possible that, especially when you use any event store, which is the library we use, each event is supposed to get an incrementing unique number. We've observed, and we only observe that, of course, in production under high load, that multiple events actually are inserted out of band. So you read a page of event because you're building a projection, and there's information missing, because that's still being inserted. The transaction is still running. But by the time you read that page of data from the event store to build your projections, there's a gap in there. Because, yeah, it's not visible, it's read committed isolation level. You load the data, you project everything seems to be fine, until people say, yeah, you know what, I missed some data. Because yeah, you actually skipped a record because that was not visible at the time you wrote for, and that's a known issue that a lot of people don't know about. That caught us a couple of months ago. We're still trying to fix that. Does it still look like something you want to use, this whole event sourcing thing? Well, again, I just want to prepare you for that. Tips and tricks. Well, there's a couple of things you can do. I actually started myself, and if you're in the .NET space, thanks. 10 minutes. I'm in the .NET space, so since I've been using this for the last 5 years, I've of course obviously learned some things over time. So I also started to blog about all my experiences and the pain points, and also started to think like, you know what? If I have to build another system based on this architecture style, how would I do it? What kind of solutions would I choose for? So I started working on my own library called Liquid Projections, which is basically a bunch of like 8 or 10 different projects. NuGet packages in the .NET space. If you're not in the .NET space, it might still be useful to check out the code, because all my open source projects are not just useful, at least I think they're useful. I may be the only user actually. But I also think the code is in there is a demonstration of what I think code should be written. Clean code, unit testing, and the whole shebang. I also hate frameworks, as I said, because they hide too much magic. So this library has a pretty high learning curve, but it provides a couple of things, like it's designed as a library, and it really thinks about, believes that projections should be autonomous, which means asynchronous. Every projector should be completely independent, because then you can make decisions on when do you replay, how often do you replay, what is your storage mechanism, maybe you project in memory because it's a pretty small set of data, you don't have to store it in a database. You want to be able to restart it, so it provides like tracking interface and APIs to see how far is it, how much data has it processed, how long is it going to take to complete, so I have some kind of weighted average calculations. It's all in there. An event store, yeah, that's for the .NET people in this room, that's what I use. It's actually, it does the job quite okay, but we've actually had to tweak it so much. We basically took the code from the open source project and merged it into our code base, because we had so many extra things like this archivability and all kinds of extra calculations and metadata that we needed. So we started to copy it. It is actually well designed in terms of being able to extend little pieces and parts of it, because essentially when you use it, it builds like a big pipeline internally, and you can, like with pipelines, you can put stuff in between until you can't. Get Event Store, that's Greg Young's own library. I don't know the real state. I just have spoken with a couple of people that kind of stopped using it. That's not a good thing, actually. You're using it? You're still happy with it? Okay, good. I saw somebody said, like, generally there were too many problems and it didn't get enough support because a number of people working on that stopped. But that's the same with any event store. And that's, at least in the .NET space, worst case, you have to build your own event store, and it's not that difficult. Kafka, somebody mentioned the last time I did this talk. I still haven't looked in detail. They said, like, why are you not using Kafka for all this stuff? It does event sourcing, it does versioning, it does routing, it allows you to track how events are being processed. There's a lot of stuff that you can use there. Well, I haven't really looked at it, so I recommend checking it out. Which brings me to the end of this small presentation. I'm fully aware there's a lot of information I spilled over this group, especially after lunch. I tried to get some hardcore music in it, but it wasn't that loud. I also don't expect you to go home and then suddenly say, oh, this is what we're going to do. The goal was to share real-life pain points, good and bad. I still love event sourcing. I will use it everywhere. Even my Hello World is now an event source system. Now it's, again, event sourcing is an architecture style. And it's not something you should use all over. You need to think about the consequences. But most talks about event sourcing talk about how great it is. Well, you can use it in aggregates. You can use it, in your bounded context. It's a great solution within the bounded context. It's not an architecture style that you should apply to your entire system. You need to think about where it applies and where it doesn't apply. With that, if there's any questions, we have 5 minutes left. And otherwise, just approach me. I'll stick around for a while. Tweet me on Twitter. That's it. Thank you.
There is a question. Yeah, that's what to say. Thank you to share all this experience. And I make some advertisement for my workshop tomorrow because I will be.
Good point.
We will be implementing event sourcing in functional programming and see how it fits with domain-driven design, how you can have clean domain-driven design, and implement it using a functional approach, which solves part of the pain you felt there. And I will talk about some of the mitigation we can have for a lot of these different topics, which most of them come from functional programming perspectives.
And you do microservices as well? That's a shame.
No. Kind of.
No, I spoke with this guy a lot last night, and he has a lot of experience there as well. So thank you for that. I absolutely recommend joining his workshop. That's it. Well, enjoy the rest of the conference. If there's no questions, and approach me if you want to.
And please leave feedback over there.
Oh yeah, sure. Over there?
Yep.
Not there. Okay.
No.
All right.
At the entrance.
All right. Yes. Thank you.
Thanks.